Okay, for Lab 2, you should have all of these files, a scripts folder with a bunch of IMU sensor collection data, and 5 images that give you the corresponding data for the IMU, right? So let's open IMU analysis. Okay. And what we're going to do is loop through each IMU sensor, right? So this is sensor calf, sensor thigh, and that repeats, right? Because we have 2 sensors on the leg, on the calf and thigh. And what I want to do with that is first, we're going to select all, we're going to go through a loop 1 to 2 because we have 2 sensors. We're going to select all of the sensor data that corresponds to the thigh. Then we're going to go through it and select the data with G input. We're going to select the data that we want from each plot. And then that'll give us our Euler angles. And then finally, we get our angles saved into a cell array. Okay, we're going to do that with both sensors. Then we're going to move on to an image. We're going to load the images we want here. Then we're going to go through each image. We're going to show it with image SC. And then we will select the hip, the knee, and the ankle. And then this code here just runs through all of the coordinates and finds the angles with respect to the x-axis, right? And x-axis is just the horizontal. So then we're going to get theta 1 and theta 2. And then we're going to compare the IMU sensor angles to the angles we found from the pictures by plotting them here. Okay, so let's go through it. Run this. First, let's select all the thigh data here. Open that, and we should get a plot. So now we can do a G input for each plot. We're just going to select the window of data that looks the best. Okay, now we go through the calf, get all of these data. Select the window that has the best data. Say something like this. Okay, now we select our images. And say open full. Now I'm going to select like a location for where I think the hip is. So just center mass there, center mass of knee, center mass of ankle. All right, something like this. Hip, knee, ankle. Okay, so now the code's going to run through, and we're going to get these nice these plots of the angles. If we go back to the code, we can see that the angles from IMU sensor are going to be red circles for the thigh versus red stars for the pictures, the images that we select the data points. And then blue is going to be for the calf. So let's see that again. Okay, so one thing to point out, right, is that circle here, which is, remember, circle is going to be from IMU sensor, right? Blue circle is from the calf IMU sensor. And the blue star are way apart for the flexion of the complete flexion of the knee. And if you look at this, this is 53 versus 133. So what needs to happen is that this point, right, needs to get plus 90, right? If it's plus 90, then it's really close to this point, and you get about 143 or something like that. So why does the IMU sensor give you 53 and the image processing give us 133? Right? Why are we 90 degrees off? Well, in the image processing code, I use a function called atan2. And essentially, atan2, if we look up on Wikipedia, it's a really nice page that describes pretty much everything about this function. Essentially, what atan2 is going to give us a definition of tangent for 360 degrees, right? We can, if we pick a point on the coordinate system in quadrant 1, 2, 3, 4, right? We can correlate that to some radian value that is positive or negative, right? And from that, we basically, if we have a set of x, y, that's x is positive, y is positive, right? Then we know that the angle is going to be positive from the x-axis, right? It's going to be between 0 and 90. let's say if x is negative, y is positive, right? Then the angle must be between 90 and 180, right? And then so on and so forth. So if x and y are negative, then we know that it must be in quadrant 3 here, and we need to have a negative angle between 0 and 180, or a positive angle between 0 and 270, or 180 and 270 right here. Right? Okay, so a tan 2 is going to keep track of the sines of x and y and give us that angle with respect to the x-axis. I believe that's what's causing this 90-degree shift. So just keep that in mind, and just take this data point 4 and add 90 to it. Okay.